Okay, yesterday we have talked about how to use matrix to represent the transformation. We have dilation and reflection given by a 2 times 2 matrix. Like a particular matrix will represent a particular transformation description. And then if there's a horizontal or vertical movement, we have a 2 times 1 matrix to add that at the back to represent the horizontal movement. So let's have a look at example 1. Okay, by looking at example 1, a transformation is defined by this matrix. Well, by looking at this matrix, you know this is a dilation by a factor of 2 from the x-axis because it's changing the y value and it keep the same y like as the x. So there are 2 ways you can do it. If this is a really simple transformation matrix, you can see immediately what it means. You can directly write out like this is x dash equals to x and y dash equals to 2y because there's a dilation from the y-axis. Or if you can't see it, well, it's alright, you can't remember all the matrix. Well, if there's a complex one, for example, there are 4 numbers in the matrix, like it's a combination matrix, you can't directly write out what that means. So what we can do is, remember I said yesterday, x dash equals to t times x. The x dash equals to the transformation matrix times the original matrix. So you can also write like x dash y dash equals to the transformation matrix times the original coordinates. What you can do is expanding that, like calculate the matrix actually, like really work on the matrix. So it's row times column, that's the row, that's the column. So the right hand side will equals to 1x and 2y. And this is equivalent to y dash and x dash. Therefore, you can have the same equation as I given here, x dash equals to x and y dash equals to 2y. And then the question, when you have this equation, this question is equivalent to the type 1 question, which is giving you the original function, means I have xy. I have x and y. So then give you the transformation description, ask you for the image. Okay, ask you for the image. So if it's ask you for the image, I have x and y. I have x and y. So I need to make xy to be the subject. Just to make xy to be the subject. So therefore, we need to rearrange that. We need to rearrange that. Well, x is already the same as x dash, but y equals to half y dash. Okay, y equals to half y dash. So what we'll do is rearrange it because I have xy. Therefore, I will make xy to be the subject. And then I will substitute that back into the original equation. A half y dash equals to x squared plus 2x plus 3. Or you can change x to x dash. That's the same thing. So y equals to 2x squared plus 4x plus 6. Okay, 2x squared plus 4x plus 6. Or you can rearrange, well, you can complete in the square, make it into the turning point form. While we don't need to put into the turning point form for this question, it's not the one asking for the transformation description. It's just a basic substitution question. Therefore, we don't really need to make it into the turning point form. We don't really need only 1x and 1y. We are not trying to look at what is the transformation between 2 functions. Therefore, we can just simply substitute the y value, y into y dash, and then rearrange it. So that will be the image. Okay, that will be the image. So that's example 1. Have a look at example 2. Example 2 says a transformation is described by the equation. Well, we always use capital letters to represent some matrix. As I said, like when we go through the chapter 2, like the matrix chapter, give you capital letters to represent the matrix. So in this equation, x dash, as I said, x dash is x dash y dash and x is xy. So we can expand that. Okay, we can expand that. Let's have a look. For this equation, is the other diagonal got the numbers and then the main diagonal got 0, 0. Like normally we should have 1, 1 at the 0, 0 place, but like 0, 0 here, which means there's a reflection in the line y equals to x. We already changed the xy values. Also, also we have dilations and reflections as well, like changing the numbers. But it's very hard to see at this point, like what has been done. Okay, what has been done. So this type will be the type I said, when you look at the matrix, transformation matrix, you can't tell what the transformation actually is. So we need to just expand the equation. So it says T is that, and times bracket times by x is xy, plus b is 1, 2, equals to x dash. Therefore, that's x dash y dash. So you need to understand, in the end, give us the transformation equation. In the end, we want to achieve x dash y dash, like x dash equals to some x, y dash equals to some y. We want to times the matrix, calculate the matrix as well. We want to get the equation in the end. So we will have 0, -3, 0, 2, 0, and then we will plus them. But remember, that's still one column. Okay, that's still one column. It's just x plus a number. So you use the row times with the column. So the first one, 0 times that is just 0. -3 times y plus 2 is the first number. And second number will be 2 times x plus 1 equals to x dash y dash. Therefore, x dash equals to -3, y plus 2, and y dash equals to 2, x plus 1. So if ask you to describe this, what I can say is, the first thing happen is make x become y, make y become x. That can be the first step. Okay, we can see the step. So x dash first become y, and then become y plus 2, and then become -3y plus 2. That can be how it changed. And then y dash can first become x, and then become x plus 1, and then become like 2x plus 1. Or you can expand it. If you want, you can expand it. That will be like the other translation factor. So we can say first is a reflection in the line y equals to x. So first of all, we swap the xy. Second, it will be translate 1 unit to the right. Sorry, 2 units to the right. And 1 unit up. Okay, it's still the change for x dash that become, like after you swap, your y is actually the x dash, the new x. So what happens to the new x? The new x is further moved by 2. So it's x dash plus 2. What you look at should be the x dash. I think some of you may think, oh, it will be 2 units up and 1 unit to the right. But no, you need to look at where's the x dash. It's the new x plus by 1, which means it's moved to the horizontal by 2 units and then move up by 1 unit. And number 3 will be dilation. There's a -3. So I can say there's a dilate by a factor of 3 from the y-axis and 2 from the x-axis. And number 4 is a reflection in the y-axis. Or you can swap number 3 and number 4. Or you can swap number 3 and number 4. Well, I don't really need to know like how to describe it. I just explain to you how this works. So there's actually like 4 transformation like steps happening like in one simple matrix. So that's why I said it's very hard to see what actually it is. We can just use the equation to expand it and then do whatever we need. Okay, so we haven't answered the question yet. Like this bottom thing is not necessary to answer that. But what we need to answer is like what's the transformed equation looks like. So we have xy. I need to make xy to be the subject. I need to make xy to be the subject. So here y equals to -1 3x minus 2 and x equals to a half y dash minus 1. Okay, I have xy as the subject. X dash minus 2 equals to 2 bracket a half y dash minus 1, that's the x, and then plus by 5. -1/3 x dash minus 2 equals to y dash, well, minus 2 plus 5 is a plus 3. So y, I can get rid of the dash, y equals to -1/3 x minus 5. Just rearrange that. So for matrix transformation question, you don't need to think about much. Like what you need to do, just by the given matrix, you're trying to expand it and come back to the x dash y dash equals to something, and either rearrange or directly substitute, depends on what you have, whether you have the resultant function or the transformed equation. So that's this question here. Okay, let's have a look at example 3. Example 3 is an important question. Do you remember, as I said, if you can do dilation, if you want to dilate from x-axis, there must be another way you can also dilate from the y-axis, right? You can always dilate by 2 different axes, result in the same function, but using different factors to do it. In some case, like you can reflect things in different axes. Like you can reflect, well, either you reflect in x-axis or reflect in y-axis, they will result in the same graph. It depends on where do you put the negative. Hyperbola is that type. Okay. Hyperbola can reflect in both axis or y-axis. Or I can say what kind of graph we can do that. Like what is called odd function. Okay, similar to odd function. You have this part. When you reflect it, it looks the same. Okay, like it's not necessary to be a odd function. Let's say odd function. The requirement for odd function is must symmetrical about the origin, right? Must be symmetrical about the origin. But have a think. Just think this graph. There's a 3, there's a 4, and you have negative graph like that. That's similar to an odd function, but it's not odd function. It's not symmetrical about the origin. But this one can also achieved by reflect in both axes, but by different translation. Okay, you translate like in the different ways, you can still achieve the same graph. Well, when you reflect in the x-axis, reflect in the x-axis. Okay, think about we have a graph like this. When you reflect in the x-axis, you can think about it. Okay, reflect. This is the x-axis. Okay, this is the x-axis. When you reflect in the y-axis, okay, think about that. When you reflect in the y-axis, okay, the blue one is the original graph. Okay, the blue one is the original graph. When you reflect in the y-axis, the green one will be the graph. Can you see that? But can you see the red graph and the green graph can be transferred between each other, like moving up by a particular units to become each other. They have the same shape, they're facing the same way. When you translate up, like the red one translate up, you will become the green one. So, well, if I want to reflect this graph by the x-axis, I can reflect it by the y-axis and moving down to have the same graph here. Okay, so you reflect in the x-axis will be the same as you reflect in the y-axis and then moving down. So this can still be achievable, like by reflecting different axes. You're not going to say reflecting x, reflecting y, you will say have exactly the same graph. No, but by different translation factors, you can become each other. So that's why I said it depends on where do you put the negative sign. It depends on whether you reflect in the x or you reflect in the y. Just show you this example. Why I said like so much things here? Because can you see A, B, C, D, E? There's only one option is correct, which means it's either reflecting x or reflecting y. You can't really tell from the beginning. It's until when you finish like calculate everything out, you know which one is correct. Otherwise, you need to go trial and error. For example, if you want to, you think it will be reflect in the x-axis, then you calculate everything, you can't find the right option. You can't find the right option. So you need to understand, well, some students stop at that point and say, oh, I can't find the right option. Why is that make any mistake? You haven't made any mistake. Your answer is correct, just not in the option. So it can be done by both ways. So it's a very tricky question here. So if I do this, when I first try this question, I put the negative sign with the y because you remember this is the hyperbola rule. We will have the rule 1 over something. Okay, everything must be under denominator and then it's a 1 on the top. So if I do this question, I'll say y equals to 1 over x, and then I'll say y dash minus 4 equals to negative 2 over x minus 3. I put the negative on top, but the top must be a 1. Therefore, I'll say it's y dash minus 4 divided by negative 2 equals to 1 over x dash minus 3. Okay, if I do this question, this is like when I first attempt to do this question, I make this form. Okay, I make it into this form. And then what I will have, I will make y side to be equal and x side to be equal. So y equals to y dash minus 4 over negative 2, x equals to x dash minus 3. Okay, in order to, let's have a think again. So when I have transformation description that is equivalent to have a matrix that is equivalent to have x dash equals to some x and y dash equals to some y. Okay, you must remember this. Okay, must remember this. So those three things can become each other. What I want to achieve in the end is a transformation matrix. Okay, I want to achieve that. So I either have the description or either I have x dash and y dash. So the quickest way is to have x dash and y dash. Okay, the easiest way is to find x dash y dash according to the equation we have already. So we'll make y dash to be the subject and x dash to be the subject. So I can directly give the transformation matrix. Okay, that's my transformation matrix. Because there's no factor in front of x, there's a factor negative 2 in front of y. I need to change the y. So I'll make the 1 become negative 2 at the red corner here. And then I'll plus a 3 plus a 4. Okay, remember this must be in the expand form. when you deal with matrix question, you must put into the expand form. If it's not in the expand form, you will do bracket. You do bracket. You bracket the translation first and then dilation. So I would recommend you do it in the expand form, okay? Because the equation, there's no bracket here. It means dilation, reflection happen first, and then translation. But let's have a look. In these 5 options, there's no answers. Can you see that? We don't have the same thing. That's why first attempt this question, I see, oh, there's no answer. Okay, the similar one is E. Okay, the similar one is E. So it's just the negative is on the X side. Well, the dilation factor half, which is not right. And B is by a different translation factor, so it can't be right at all. So B can't be right at all. So dilation factor half is not going to work. Okay, the dilation factor doesn't matter you reflect from which axis. It shouldn't change. Okay, it shouldn't change. Dilation factor will keep the same. So A can't be right as well. So the only possible option must be E. Okay, but look at this, the only option must be E. Just remember your dilation factor is not going to change. Well, unless it's dilate from different axes. If it's dilate from the same axis, where the reflection happening is not affect how do you dilate by the x-axis or y-axis. So the factor shouldn't change. Also, B is by a wrong translation factor. So B can't be right either. So the E will be the only correct option. That's when you don't know what to do, you can really guess the answer. That's how you can guess the answer. But if you want to really work on this, you can think about, okay, just analyze that answer E, which means there must be a reflection on the X side, which means the negative sign can't be on the Y side. It must combine with the X. Okay, it must combine with the X. So if you combine with the X, this negative, use a red color, this negative here shouldn't be there. It should go bottom, combine with the X. So I will rearrange the top equation. I'll say y dash minus 4 over a 2 equals to 1 over a negative bracket x dash minus 3. Remember, when you put the negative top or bottom, is negative the whole thing, negative everything. So you put the negative sign down and then just divide the pure 2 on the other side. Now, like the x is associated with the negative, not the y. There's no reflection on the y side anymore. And then we have y equals to y dash minus 4 over 2 and x equals to minus bracket x dash minus 3. So y dash equals to 2y plus 4 and x dash equals to negative x plus 3. So now x dash y dash equals to negative 1, 0, 0, 2 xy plus 3 and 4. According to those two equations. So the answer will be E. Okay, so the answer will be E. That's, well, if the first time you put the negative sign under the bottom, lucky, you just get the right answer. But if at the first time you put it like me, like put on the other side, you just can't get the right answer. Well, two things you can do. Just if you know the rule, you can retry it. Okay, I know it should be, maybe it should be with the x, so I will redo the question. Or you can use my method to just reject all the impossible solutions and the only thing left is E. Okay, two ways you can do this question. That's example 3. Okay, next one's example 4. Example 4, the matrix which determines the transformation dilation from the x-axis of a factor of 2 followed by a dilation from the y-axis of factor 3 and then reflect by the y-axis is given by. Okay, I want to determine one matrix for three things happening like with this order. So the first thing happened is from the x-axis, a factor of 2. okay, 1, 0, 0, 2. From the x-axis is changing the y value. So you have 2 at the right corner. Followed by a dilation from the y-x-axis. A dilation from the y-x-axis. Change the x. Mass times that in the front. Okay, mass times that in the front. Remember, the order how it happens must be go to the front. Okay, not times at the back. The order will make a difference. Okay, the order will make a difference. And then reflect by the y-axis is changing the x. It's not on the same line. So annoying. 1, 0, 0, 2. Okay, so now that's in the line. That's how we should write the order. So that's my first transformation, that's my second transformation, and that's my third transformation. It must happen within this order. Okay, it must be within this order. So row, column, and column. What I will have is -3 for the first spot. Okay, -3, 0, 0. 0 and 0. You have 0 here. 0 and, wait, that place is 0 and 0. 0 and 1. That's the first two. You can see if you get this in the wrong order, you still result in the same thing. Okay, you still result in the same thing. Why? Because the dilation and reflection is not affecting each other. Which one happened first, which one happened second, doesn't really matter. But if there's like reflection in the line y equals to x or something like that, that will make a difference. So this question just tell you you should write things like all into the front. And also I remember there's a question, I can't remember whether it's a year 11 book or year 12 book. There's a question you must follow that order, otherwise you can't get the right answer. So everything needs to times into the front. Doesn't matter like for this question, if all those doesn't matter, but I still want you to get the right order to work on this. So the next one, row and column. You have -3 and 0, 0, and 2. So that's the transformation. Well, I can write it out directly. I can write it out directly because it's a reflection and 2 dilation. I can already know that will be my answer, but just show you how should you write this matrix. How do you get the order right? Okay, do we have any questions? If you don't have any question, tomorrow we will, tomorrow is the graph. Okay, so I want you to use the rest of time to try examples 13 and 14. We finish up almost everything. Just one more thing to go is the graph, okay, how you can see things from the graph. It's very easy for tomorrow's lesson, but this challenging question here is quite good. It's help you to work on the matrix, get a clear idea on how matrix works. So I want you to try this question before I start. You have like 30 minutes today, and you can use some of the time tomorrow as well when I finish the previous 2 pages. And then we can go through that on the Friday class.